Hello, I'm going to be doing problem number 33 from the physics book. So the problem states an unstable atomic nucleus of mass 17 times 10 to the negative 27th kilograms initially at rest disintegrates into 3 particles. One of the particles of mass 5 times 10 to the negative 27th kilograms moves in the y direction with a speed of 6 times 10 to the negative 6th meters per second. Another particle of mass 8.4 times 10 to the negative 27th kilograms moves in the x direction with a speed of 4 times 10 to the 6th meters per second. The objective is to find the velocity of the third particle and the total kinetic energy increase in the process. So let's first draw this out. Okay, so since it says that the nucleus is originally at rest, I'm going to just draw a nucleus at the origin. So it says one part moves up in the y direction, so this is going to be the mass 1 and the volume 1 in the y direction. A second part goes into the x direction. And since this is a conservation of momentum problem, and we see that this moves in the positive y, positive x, we can see that this is the third piece is going to have to compensate for that and go into the negative y in the negative x direction. So this is going to be m3 v3. So we can assume that both components of our velocity is going to be negative once we solve for it. So let's next find out the mass of part 3. So we're going to have and these are all going to be times 10 to the negative 27th, but the whole nucleus is 17. Then mass of part 1 is 5, and then the mass of part 2 is 8.4. So that one is going to be 3.6 times 10 to the negative 27th kilograms. Okay. So let's set up our conservation of momentum equation. So it's going to be m naught v naught is equal to m1 v1 plus m2 v2 plus m3 v3. But we know that there's no velocity for the first one because it says because it says it's at rest, so that's going to be 0. And we're going to be solving for velocity 3, so we're going to do v3 is equal to m1 v1 plus m2 v2 divided by negative m3. Okay, so mass times velocity, the momentum for number 1 is 3 times 10 to the negative 20 kilogram times meters per second in the j hat direction. And then the momentum for part 2 is 3.36 times 10 to the negative 20 in the I hat direction. And then we're going to divide it by the entire mass of part 2. Of part 3. And that is and it's going to be negative 3.6 times 10 to the negative 27th kilograms. So when we solve for the velocity, and I'm going to put the I hat vector first and then the j hat second, it's going to be negative 9.33 times 10 to the 6th meters per second in the I hat direction, and negative 8.33 times 10 to the 6th meters per second in the j hat direction. So this is part A. Now for part B, we're going to be trying to find the total kinetic energy increase in this process. And if you took chem last year, you were probably going to be thinking about E equals mc squared, which that's the first thing that came to my mind. But if you remember, the m for E equals mc squared is the change in mass of the change from the total atom to the different components once it decomposes and disintegrates, which we are not given, so we can't use that. So the next step, now that we see that we have mass and velocity, we could use kinetic energy. So I'll do E equals 1/2 m1 v1 squared plus 1/2 m2 v2 squared plus 1/2 m3 v3 squared. So our first step also is to figure out the magnitude of the velocity of v3. So if you remember, it's negative 9.33 times 10 to the 6th I hat plus negative 8.33 times 10 to the 6th j hat. So in order to get the velocity of it, you would square this component, and you'd square this component, and you'd square root it, and that gives you the velocity, the magnitude of the velocity. And then that's going to equal 1.25 times 10 to the 7th. So that's just for reference, but I'm going to give all the values for M1 and V1, the total value. So 1/2, and then that, or I guess double the kinetic energy for that first piece of mass is 1.8 times 10 to the negative 13. That second part is 1.34 times 10 to the negative 13. And this third part is 5.62 times 10 to the negative 13. And when we divide it, we get our total, and this is all going to be joules because it's going to be meters per second, kilograms times meters per second times meters per second. So that's in the unit joules. And once we divide that all by 2 and add it all together, it's going to equal 4.23 times 10 to the negative 13 joules. And that's slightly different than what the book gives, but it's due to rounding, like when we rounded our velocity and stuff like that. So this is the answer for part 2. Let me know if you have any questions, and thank you for watching.